Today, lesson 12C, we finish off the idea of compound events and sample space. And so we're just continuing on what we talked about in lesson 11C. So we continue along the ideas of perhaps using tables or a list or a tree diagram to find the actual sample space. And then from there, we find the probability. All right, so let's get started. Number one, after we go through the background knowledge where we've talked about these ideas, what probability is, how to find it, what the range of answers could be in terms of probability. We've defined what an event is and an experiment and a trial. And then from there, what outcomes and sample space are and how to actually find that sample space. And we've defined exactly what theoretical probability is. These are slides you've seen over and over and over again. Then we defined last lesson what compound events are. And then we've talked about tables and lists and tree diagrams as far as finding the sample space, like in this one right here. And then once we have that sample space, actually finding the probability is pretty simple. And so on. And just make sure if you write your probability as a fraction, which is the preferred, that you simplify that probability. All right, here we go. Number one, Sam and Joe are playing a game of rock, paper, scissors. What is the probability that at least one person will show rock? Everybody know that game? Rock, paper, scissors? Yes? Okay, and if you watch The Big Bang Theory, they took it to a new level. What did they add to it? Spock, yes. Rock, paper, scissors, Spock. But we're going to stick with rock, paper, scissors. The probability is, what is the probability that at least one person will show rock? Well, the easiest way is to use some sort of method, whether it be a tree diagram or a table or a list, to figure out that sample space. I'm going to use a tree diagram. So we have Sam, and Sam could either choose rock or paper or scissors. And I'm just using capital R for rock, capital P for paper, and capital S for scissors. Then we have Joe. Well, if Sam chose rock, Joe could obviously pick rock or paper or scissors. And if Joe picked paper, chose paper, Sam picked paper, then Joe could pick rock or paper or scissors. And then if Sam chose scissors, obviously Joe from there could pick rock or paper or scissors. So there is a listing of the sample space, which would be rock, 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 paper, rock, scissors, paper, rock, paper, 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 scissors, scissors, rock, scissors, paper, scissors, scissors. And of course, if you're actually playing the game, some of those you would have to go again. But we're just trying to figure out if they both did it once, what's the probability that at least one person will show rock? Well, once we have that listing, and here it is in the form of a table, and I've already kind of mentioned what the sample space would be from the tree diagram, but we can get that from the table as well. There is a listing of the sample space right there. And there are how many different outcomes? How many? 9. The question is, out of those 9, how many of them occurred where at least, and the key words there, at least one person will show rock? Well, there's one, there's another, there's another, there's another, there's another, and that is it. So we have 5 out of the 9 outcomes. So the probability that at least one person will show rock is 5/9. Very important to make sure that we get our sample space, no matter which method we used. And some of you, I know, can just jump straight to the sample space, and that's fine. Just be careful if you're doing it that way. All right, so let's go to number 2. At a smoothie stand, you can order a fruit smoothie in 3 different sizes, either small, medium, or large. You can choose strawberries, mango, or grape as far as flavor goes. And then you can add yogurt or not, depending on whether you want it or not. If all the types of smoothies are equally likely to be ordered, what is the probability that someone will order a smoothie with mango and yogurt in it? So here's what I want you to do with your shoulder partner. Figure out which method that you want to use to find the sample space, and then once you have the correct sample space, then take that sample space and find the probability. I'll give you about 2 minutes. Go. So there's no specifying in this one how to find the sample space, and most of the time that's the way it's going to be. We've talked about several different methods. It's up to you on doing that. But in this problem, we have 3 sizes to choose from: small, medium, or large. And so if we choose a small smoothie, we have 3 different flavors that we can choose. We can choose either strawberry or mango or grape. And the same thing if we choose a medium, any 3 of those flavors. And the same thing with large. And I'm, of course, using a tree diagram. And then, once we choose flavor, we can either choose with yogurt or not. So we could choose a small strawberry with yogurt or a small strawberry without yogurt. And the same thing for every single size and flavor. So that's my entire tree diagram. You didn't have to do a tree diagram. You could have done it any way that you wanted to. But listing things out like this helps with the sample space and possible outcomes. The question here is, if all types of smoothies are equally likely to be ordered, what is the probability that somebody will order a smoothie with mango and yogurt in it? Well, we can see over here that we have 18 total, and I didn't circle the last none down there. There we go. We have 18 possible outcomes. But what we're interested in is mango and yogurt. Well, here's one with mango yogurt, here's another one with mango yogurt, and then a large with mango yogurt. So we have 3 out of 18, 3 desirable outcomes out of 18 possible outcomes, but of course we should always simplify, and that simplifies to 1/6. So the probability is 1/6. All right, we've got one problem left for today, and that is number 3, which is similar to number 2. A sandwich shop offers a choice of white or wheat bread, 3 choices of meat, turkey, ham, or salami, and 3 choices of cheese, Swiss, American, or cheddar. Find the sample space by one of the methods we have discussed, and then answer the 2 other questions, which are, what are the total number of outcomes, and then, what is the probability that someone will order wheat bread with either turkey or ham? Work on that with your shoulder partner, just like number 2, and I'll get back to you in a couple minutes. Now, you've heard me say this over and over and over again this year. You know, every problem in each lesson is selected for a reason. And the reason for this one is I heard conversation about, a little bit of confusion about, well, but what about the cheese? What about the cheese? It could be any of the cheeses, right? Well, I don't have to say wheat bread, find the probability of choosing wheat bread with turkey or ham and then with Swiss cheese. I could have, but I left it out for a reason, for you to think about that. And so we should start by listing the sample space. And by the way, we could have found the number of outcomes without even listing it out, because there are 2 choices for bread, 3 choices for meat, and 3 choices for cheese. We could have used the fundamental counting principle, 2 times 3 times 3, which gives us 18 possible outcomes, which of course is the denominator of our probability before we simplify. Or we could find it by listing out the sample space. So we have 2 kinds of bread, white or wheats, and then from the white you could have chosen a sandwich with white bread and then either turkey or ham or salami. And then from the cheese you could have chosen white bread with turkey and then any one of the 3 different cheeses. And it works like that, or 2 cheeses, sorry, not, wait, 3, there's 3. There's Swiss, American, and then cheddar. That's 3 different kinds of cheese. Same thing with ham, same thing with salami, and then it will work just like that for wheat bread. Wheat bread can come with turkey or ham or salami, and then on each of those, each of the 3 different cheeses. And so once you do that, if you didn't use the fundamental counting principle, you should have seen right here that you have 18 total possible outcomes. But what we're interested in is we are interested in the probability. Let me go ahead and answer the first question. There are 18 outcomes. The probability that someone will order wheat bread with either turkey or ham. Well, here's wheat bread, and here are all the possibilities with turkey or ham. So there are 3 here and 3 here, and that gives us 6 desirable outcomes out of 18, which simplifies to 1/3. So the probability is 1/3. Okay? Any questions about number 3? All right, we are finished.